Hello everyone. Today we're going to discuss a very important topic from 9702 AS syllabus, that is vectors and scalars. And in today's video lecture we will study about the basic concepts of vectors and scalars, and then how to add the vectors and how to split a vector into its two components known as the perpendicular components. So let's start with the basic introduction of vectors and scalars. So about scalars, we know that it's just magnitude and unit, while in vectors, it's magnitude, unit, and direction, which is important for the complete description. If we look upon the examples of vectors, they are less in number, like displacement, velocity, acceleration, force with all the types like weight, friction, upthrust, air drag, viscous force, moment of force. All these are actually the effects of force or the type of the force, so they are vector, and then the momentum is the vector. So five vector quantities, and rest of all are scalar: distance, speed, area, volume, density, work power, energies, pressure, current, resistance, charge, etc., etc., because there are too many. Okay. About the symbols, vectors are used with the normal letters, and while the the scalars are with the normal letters and the vectors with the bold letters, and they have the graphical representation as well. So we represent them with line. So this is the line, and the length of the line represents the magnitude of the vector, and the arrowhead represents the direction. Okay, the next important thing is adding up coplanar vectors. So the rules that we will follow will be the simple IGCSE rules, and these, and what is meant by coplanar vector? Coplanar vector is the one which act in the same plane. So actually it's just a simple term that we use. It has no other significance. Whatever question will be in the A levels, it will be the coplanar vectors. Okay, so there are three rules. The first rule is if the vectors are in the same direction, angle 0, you simply add them. If the vectors are in opposite direction, angle is 180 degrees, so you subtract them. And if the vectors are perpendicular, right angle vectors, then there are two things. Either you use the Pythagoras theorem to get the resultant of those, or you use the trigonometric ratios sine, cos, and tan. If we quickly look upon this example where f1 and f2 are the vectors, which are the right angle vectors, and r is their resultant. So f1 and f2 are known, we know their value, their angle is 90 degree. So you have to find the value of their resultant r. So what you do is you use the Pythagoras theorem, which is hypotenuse square is perpendicular square plus base square. Okay, so hypotenuse is the resultant over here, and then the perpendicular and the base, you just add them, you just add their squares, and then you take the square root of both sides to get the value of the resultant. Okay, the second rule is when like one of the vector is known and you know the angle of the resultant as well, but the other two are unknown. We don't know about the other two, like we don't know about f2 and we don't know about the resultant vector. So what to do then? You have one side and one angle known. So for that you use the trigonometric ratios, which is some people have curly brown hair through proper brushing. So it's sine theta, cos theta, and tan theta. Everyone knows this. Okay, so you can use either one of them. For example, in this case, if you see that f1 is known, which is actually the base, and you have to find f2. So this is perpendicular. So you will look for the ratio in which perpendicular and base are involved. So that is tan theta. So you will say tan theta is perpendicular, which is f2, over base, which is f1. You have to find f2. So you shift f1 to the other side. So that's how you can get the value. And as you know f1 and you know the theta, so you can easily find f2. How you represent or add the vectors graphically? So in order to represent the vectors graphically, what we do is we represent them with the line. So this line and the arrowhead. So this line and the arrowhead, line and arrowhead, line and arrowhead. So all these vectors are acting in different directions. So you have to remember one thing: do not change the direction or length of the vector if you are adding them according to the scale. Like you choose a scale, then don't change their length or direction. What is tip to tail rule or head to tail rule? This is very famous. You must be aware of it from your IGCSE knowledge. Tip to tail rule is that vectors are added in the shape of the triangles. Vectors represent the side of the triangles. You join the given or the action vectors using tip to tail rule, and then the resultant is the one which is not aligned according to the tip to tail rule. So we can look upon an example um, to further build our concept on this tip to tail rule method. So you can see here in the diagram, an aircraft's velocity in still air is 42, but the wind speed is 23, which is acting at 54 degrees to the north. So you have to, these two are called the action vectors. So these are the action vectors because they are given in the diagram. So what do you do? This is your vector 1, this is vector 2. So what you do is you first draw your first vector, and this is not to the scale. Remember, this is not to scale. You're not choosing any scale, so you can choose any length. That's not a problem. So this is 42 meter per second, and then your second vector, according to head to tail rule, you don't have to change its direction. Obviously you will be drawing it over here, so I'll be drawing it over here. So this is wind with 23 meter per second. So you draw it here. So these are the alternate angles. So this angle is 54 as well. So this is your 54. So these are the action vectors. So what you do is you represent them with the side of the triangle, and then you have joined them, and then you are going to find the resultant. So how you're going to find the resultant? That's how you are going to find the resultant. So this is your resultant vector, or this is your resultant velocity, because it starts from the tail of the first and it end up at the head of the last. So as I told you that the resultant vector is not aligned according to head to tail rule. So this is the resultant. So that's how you draw your diagram. Now about the rules, how to find this value of V. If the angle in the question is 90 degree, which is not 90, which is actually 54. If it is 90, you use Pythagoras theorem or you use the trigonometric ratios, as I told you before. Remember, if one of the angle in the triangle is 90 degree, you have to use Pythagoras theorem or trigonometric ratio to get the unknown quantity. But if the angle is not 90 degree, it is something else. Like in this case, it is 54. So if it is other than 90, then you can use sine rule or cosine rule. Even if it is 90, you can use sine or cosine rule, but for 90, the better one is Pythagoras theorem or the trigonometric ratios. So what are the sine rule and cosine rule? Sine rule, this is the sine rule: a over sine a, b over sine b, c over sine c, where a, b, c small letters are the sides and capital A, B, C are the opposite angles. Like a opposite to a is a angle, opposite to small b is b, opposite to small c is capital C angle. And the cosine rule: a square is b square plus c square minus 2bc cos a. B and c are the known vectors, and this a is the angle between b and c sides. Okay, so you use sine and cosine rule. Sine rule is used when two sides are one angle is given, or two angles are one side is given. Cosine rule is very, very famous, and it is used more than sine rule when two sides and one angle between them is given and you have to find the third side. Then you will use the cosine rule. Let's do it through an example. Suppose that there's a box which is under the action of two forces, 10 Newton and 8 Newton, and both are at 90 degree angle as shown over there. So you have to find the resultant force acting on it. So what you do is you aligned these two vectors according to head to tail rule. So first you draw 10 Newton and then you draw 8 Newton following head to tail rule. This is head and this is tail. Okay, so then you draw the resultant. So this is your resultant vector. So this is 8 Newton. So obviously you will say applying the Pythagoras theorem, hypotenuse square is perpendicular square plus base square. So this is resultant R, which is equal to 10 square plus 8 square. Then you take the square root of it to get your answer. So this is 164 square root. So you can get your answer over here. Okay, example 2. A swimmer is swimming in a river in which water is flowing at 4 meter per second and it is flowing horizontally. The swimmer is going at an angle of 70 degree to the one of the river bank. You can see over here it is at 70 degree to this river bank and its speed is 2 meter per second. What is the question? The question is find resultant velocity of swimmer. Okay, so it's the same question as the above. There are two vectors, one is the water flow, one is the swimmer speed. So you align them. So if you first make the water flow, because that is straight horizontal, so you will make it like this, 4 meter per second, and then you will draw the swimmer according to head to tail rule. You don't need to change the direction. Its direction is almost this. A little change can happen, but the main direction should remain the same. And you can see here it's a 70 degree with the horizontal, so which is parallel to this water flow. So actually the angle is this, which is 70 degree. And now you have to find the resultant. So the resultant velocity of swimmer will be in this direction and this will be the angle. So if you want to find V, you know the angle between them is not 90 degree. It means that either you are going to use sine rule or you are going to use cosine rule in it. So we see that two sides and angle between them is given, right? So look, these are the two sides and this is angle. So two sides and the angle given. So you can see rule number 2, when two sides and the angle between them is given. Okay, so let's use this rule over there, cosine rule, because we now have two sides and the angle. So we say using, remember in these question mostly cosine rule is used. Okay, so cosine rule is v square equal 4 square plus 2 square minus 2 into 4 into 2 into cos of angle between them. And what you do is you solve it and then you take the square root of this to get your answer. I don't have the calculator at the moment with me, so just calculate it yourself. Okay, then for the direction of V. Okay, but the direction of V means the angle. Actually you have to find the angle. So in order to find the angle you will be using the sine rule. You can use sine rule over here. So let's say it is 2 over sine theta equals V over sine 70, because V you just have figured out from there and you can find theta from here. So you just cross multiply and you make sine theta as the subject. So it will be 2 sine 70 over value of V, and then after this what you're going to do is you are going to make theta as the subject and shift sine to the other side. So it will be sine inverse this. You just put the value of the V from there, whatever value of V, and you take the sine inverse of this and you will get the value of the angle. Example 3. Okay, just pause the video and try to solve this question yourself. Okay, I hope you have solved this question. Let me quickly solve it for you. You can see here again it's the aeroplane case. It's 42 meter per second and the wind is 23. Is actually the same question as we have done it over here. So we just made the diagram over there, so we can refer back to this diagram as well. You can see that you have 42 meter per second, you have 23 meter per second, and the angle between them is 54. So you have to find the other side. It means again two sides and angle between them is known, so you have to use Pythagoras theorem over here. Sorry, not the Pythagoras theorem. Actually, you have to use the cosine rule over here. So again, this is your first vector, which is 42. This is according to head to tail rule. The next vector, this is important that how you draw it. So you will normally draw it over here. So this wind will be over here, and then opposite angle is 54. So this angle will be 54. And then this vector will be the resultant velocity which you have to find. So we say using cosine rule. Using cosine rule, so v square is 42 square plus 23 square minus 2 into 42 into 23 cos 54, and then you take the root of this to get the value of the magnitude. Okay, representing vector triangle with the equation. This is another concept which is very important but very simple. Let's say I have drawn two vectors. This is vector P and this is vector Q. They are arranged in head to tail rule. And then this vector R is their resultant. So we can write the resultant vector as sum of vectors arranged head to tail rule. Okay, so whatever vectors are arranged in head to tail rules, what you have to do is you have to add them. So this is P plus Q, and they are always equal to the resultant. And remember, the resultant is always tail tail and head head. So the tail tail and head head one is the resultant, and the one which are arranged head to tail rule, you add them. So this is actually the equation, and this is the diagram of these vectors. Okay, if you look upon this one, so we can see, first we have to see how many of them are arranged in head to tail rule. So this is F1 and this is F2. So you can see both of them are arranged in head to tail rule. So you add them, F1 plus F2. And as this R is again the resultant, because this is tail tail and head head, so this is the resultant. So F1 plus F2 is equal to R. That's like quite simple thing. So remember one thing in the vectors. The vectors arranged in tip to tail rule are always added in the equation. Like whatever vectors are in head to tail rule, they are always added. There is always a plus sign between them. The vectors in the triangle with tip tip and tail tail, where it is, look in the diagram, tip tip tip, tail tail. So that vector is very special because that vector is called the resultant vector. What is the negative vector? This is another concept that we have to study. Suppose there is a vector A acting in this direction, 1, 2, 3, 4, 5, 6, 7, 8 blocks long. There is another vector which is 8 blocks long, but its direction is opposite. So vectors A and B have the same lengths, but they have the opposite directions. So these two vectors are called negative vector of each other. So we say vector B is a negative vector of vector A, or we can say vector A is a negative vector of vector B. So from this diagram, we can understood the definition of the negative vector. So we can sum it up as a vector having same magnitude but opposite direction is said to be a negative vector. So every vector is having a negative vector. That's quite simple. If I draw two units of vector this P and I ask you, okay, come on guys, draw a negative vector of this. So what you do is you draw a parallel vector to it of same length but opposite direction. So you will say, sir, here you go, this is the negative vector. So we will say P is equal to negative Q, or we can write negative P is equal to Q, because as both are in opposite direction, so we have to assign negative sign with one of them. Let's look upon the example. Well, this example is vector addition with negative vector. So this is vector P, this is vector Q. And they are asking you to draw a vector R such that this equation validates. P minus Q is equal to R. Remember, in vectors, you never subtract the vectors. You actually add them. So we can write it as R is equal to P plus minus q, because plus minus minus, right? But actually this negative q is the negative vector of q. So I already told you that negative vector is one which is having the same magnitude but opposite direction. So this is negative q. So what you do is you just add them. So how you add them? Let's say this is your vector p, right? And then you have to, sorry, I have to draw it somewhere else because that vector is pointing upward. So this is your vector p and you have to draw your vector q. So the vector q will be that direction, actually negative q. So as they are in head to tail rule, head to tail, that's why you added them. So you say p plus minus q and then you have to make their resultant. So the resultant is this one, because the resultant is always tail tail head head. So this is your resultant. So this is equal to r. And then okay, so then you can say p plus minus is minus, q is equal to r. So this is the diagram for that. This will be coming in MCQ where they can ask you to look for the direction of r if p and q are given. Okay, let's look upon example 2. This is from the past paper. This is vector p and this is vector r, and they're asking that you have to find which diagram is correct, which will prove this, that x is equal to p minus r. So again it's the same thing. You never subtract vectors, so you'll say x is equal to p plus minus r. So minus r is a negative vector of r. So it will have the same magnitude, same length, but opposite direction. So this will be minus r. So what you do is, if this vector is your p, then according to head to tail rule, this vector will be your negative r vector. And then obviously the resultant should be like this. So this should be your resultant. So one way is this: x is equal to p plus minus r. So x is equal to p minus r. Okay, that's fine. But if you look in the diagram, you can't find, or maybe you can find, yeah, you can find in which x is upward, yeah, minus r, but no, this r is downward, so this cannot be the option. This cannot be the option, this cannot be the option, not be the option. But of course one option is correct, but they're using the other method. Now let's look on the other method. Like, there are other methods as well. So one way is this one. Now let's look upon the other way. The other way is other way to handle this equation. Okay, now what we are going to do is, I'm just going to erase this to just generate some space in which I can write the answer. Okay, so we can say that this x plus r is equal to p. This is another way. Just shift r to the other side. Now you see that see the diagram in which x and r are arranged in head to tail rule. So x and r. So if you can see in option A, x is upward and r is downward, so they are in head to tail rule, head tail, and then this is tail tail and this is head head. So p is the resultant. So yeah, p is the resultant over there. So option A is correct. But if you look upon option B, x and p are in head to tail rule, so its equation will be x plus p, and then this is tail tail, this is head head, so that will be equal to r, but that doesn't fulfill the equation. And C and D cannot be the option. Okay, let's now look upon the last concept, which is vector resolution, which is very important concept. It is actually opposite to the vector addition. In vector addition, you add two vectors to get the one vector, but over here you will have one vector, but you will split it into two vectors. So the process of splitting one vector into its two components, one along x-axis and second along y-axis, is known as vector resolution. So let's look that this f is the vector which is between x and y, and its angle is theta with x-axis. So what you're going to do is you're going to split in the two parts. So how you're going to split this in the two part? The first part will be this one, which will be acting along x-axis. So this will be fx, and the second part of this will be acting along y-axis, and this is called fy. So these fx and fy are called the components of this vector. And when you divide this vector into two components, so actually this vector is gone then, because you have actually split it in this into the two vectors. So this vector is gone, right? But obviously at the moment I'm just telling you about this, so I have to return this f factor to the original position. So what the fx value and fy value equal to? The fx is always equal to f cos theta, and fy is always equal to f sin theta. In fact, the component of the vector which is adjacent to angle is always f cos theta. So this is always f cos theta, the one which is adjacent to angle wherever it is, and the other component is of course f sine theta. And how we know that this is f cos theta and f sine theta? We can have a little triangle of this, like fx, fy and f. These are the three vectors, so you can make a little triangle of this. First of all, you draw fx, then according to head to tail rule you are drawing fy. So this is fy, and then you are drawing this f, which is resultant, because this is tail tail and head head, and this is the angle. So then you use the trigonometric ratio to find the value of fx, which comes out to be f cos theta, and then again the trigonometric ratio to find the value of fy, which comes out to be f sine theta. So just remember that adjacent to angle is always f cos theta, and the other one is f sine theta. Okay, so these are called the perpendicular or rectangular components. Why? Because f sine theta and f cos theta, they are actually at 90-degree angle to each other. So that's why these are called rectangular or perpendicular components. Okay, so adjacent to angle is always cos theta, that I already told you. Let's do an example of this. There's a vector 200 Newton acting at an angle of 45 degree to the horizontal axis or the x-axis. What you have to do is you have to find the horizontal component and vertical. So what you do is you resolve it. So this component which is parallel to x-axis or the horizontal one, this is adjacent to angle. Remember, I told you that adjacent to angle is always cos. So this is 200 cos 45. And then the other component which is perpendicular to this cos is the sine one. So 200 and sine 45. So horizontal is 200 cos 45, and you will put this in the calculator. Cos 45 is 0.707, so it is actually 141.4 Newton. And the vertical one is 200 sine 45. Sine 45, you know, have the same value as cos. It is 7 point this, so it means it has got, so both components have got the same value. Let's look upon example 2 now. There's a vector velocity which is acting northeast direction at an angle of 60 degree to the north. They're saying find the components of the velocity along north and along the east. So what you do is you have to resolve it. So when you resolve it, the first component which comes out to be adjacent to angle, remember adjacent to angle is always cos, so this is 25 cos 60, and the other component which is acting right angle to the first one is 25 cos 6 25 sorry sine 60. So this is sine 60. So remember, you have to use only 60 degree, don't use this 30 degree again. So just use the one angle. Okay, so we say that along north Vn is 25 cos 60. Cos 60 is 0.5, so it will be 12.5 meter per second. And along east, V east is 25 sine 60. And sine 60 is 0.707, So you will get your answer from there. Okay, let's look upon some tricky concepts. And the first one is finding a component using known component and the angle. So if you look in the example, this vector f is resolved in two components, fx and fy. You know fx, but you don't know fy, but you have the angle of f given over there. So what is your target? Your target is to find fy. Okay. So you will start from the thing that you already know. So you know that fx is 20 newton, and you already know that this fx is equal to f cos 30, f cos theta. So this is 20. So from here you find f, which is 20 over cos 30. So you will get some value, which is 0.866. So you'll get some value over there. And then after this, what you will do is you will say, okay, I know that fy is equal to f sine 30. So f is this one, which you have already determined. Again, I am not using the calculator, so I'll just write this fractional value, and sine 30 is 0.5. So that's how you will get your value. It's 10 over 0.866, right? So you just solve it to get your value. The other tricky concept is finding the vector magnitude and the angle using the given rectangular components which are known. This is opposite to what we are doing. We know that fx is 10, fy is 20, but we don't know how much was f and how much is theta. So how to do this? So this is done using the vector triangle method. So what you do is you arrange given vectors in a triangle. So just make a triangle. So the first vector is fx, which is 10. Okay. The second is fy. You have to arrange it according to head to tail rule, right? So this is fy, which is 20 newton, and as both are 90 degrees, so both are 90 degree over here. And then the third side is, of course, this side f, which you have to find, and this is the angle which you have to find. So as you know the two sides, and you have to find the third one, so obvious, and it is a right angle triangle. So which rule you're going to use when you know two sides and angle is 90 degrees? So what rule you use to find the third side? Tell me the answer. Yeah, that's great. Pythagoras theorem. So you use Pythagoras theorem. Okay, so you will say f square is 10 square plus 20 square, and then you take the square root. So this is 100 plus 400, so this is 500 square root. So this will be your answer. You just convert into the decimal. Okay, about the angle, you will use any trigonometric ratio. For angle, you use trigonometric ratio. Which ratio you're going to use? You have all the sides, so you can use tan theta. So tan theta is 20 over 10, because this is perpendicular over base. Some people have curly brown hair through proper brushing. So through proper brushing. So theta is tan inverse 20 over 10, and you get your answer of theta. Next is variation in value of a component. Sometimes it happens that they will tell you that, okay, this is f, which is at angle theta, and gradually you're moving it for upward, right? Let's say you're moving f like this, here, 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 and here. So you're moving all the way from here to here. So they have told us that if the angle is 0, then increases to 90, how the value of fx and fy are going to change. So first you see fx is equal to f cos theta, because it is adjacent to angle. So adjacent to angle is always the cos theta. And the component that is right angle to that is fy, which is sine theta. So fy is f sine theta. So what you do is you say that ff is constant, but the angle is changing. So as the angle increases, you know, it is cos 0 or cos 90. So you know their values. So cos 0 is 1, which is f, and cos 90 is 0, which is 0. It means that you can see from here, yeah, that if the angle is 0, then fx is maximum, right? So we say if angle is 0, then fx is maximum. But if angle is 90 degree, then fx is minimum, which is 0. What about fy? You know, f sine 0 is 0, and f sine 90, sine 90 is 1, so that is 1f. So it is opposite to that. So we say that if theta is 0, then fy is 0. And if theta is 90, then fy is maximum. So it means we will say as this vector f is going over there, then the horizontal component is decreasing and vertical component is increasing. Take a moment to recall this concept again. Okay, let's do the final example. There is a rod which is held by a rope, and the angle and the force in the rope is 38 Newton. This is tension, and it is at 60 degree with the horizontal. They are saying that find the horizontal component of the forces exerted by the post by the wire connected at point C. So you have to find the horizontal component. Okay, so let's resolve it. When you resolve this, adjacent to angle is horizontal, so this is 38 cos 60, and then this one which is vertical will be 38 sine 60. So as they're saying only horizontal, so we will say it is 38 cos 60, and 38 and cos 60 is 0.5, so it is 19. So your answer is 19 Newton. Okay, so that's it, everyone, for the today's lecture. This was all about, this was the phase 1 of the basics of the vectors. If you just look upon this, we are done with the syllabus headings of the unit 1. We learned what are scalars and vectors. We learned how to add the coplanar vectors. We learned head to tail rule. We learned how to write the equation of the vectors by graphically drawing them. And then we learned what is resolution of vector. Resolution of vector is opposite to addition of vector. In addition of vector, you add two vectors to make one. In resolution of vector, one vector is given, you split it into two components. And that's very interesting because the two components are always at right angle to each other, always at right angle to each other. And the vertical component is f sine theta, and the horizontal, if it is adjacent to angle, is f cos theta. So remember one thing, any component of vector that is adjacent to given theta, that will be cos theta. Remember that thing. See you in the next video, inshallah.